So good morning students. So we are doing Pythagoras theorem theoretical problems. This is for 10th state and Cbse. So Icse they don't have this syllabus. Theoretical problem based on Pythagoras, they can ignore it. If you want, if you are really interested, you can also listen to this. This is quite interesting chapter and this is completely based on theoretical problems. Let me read out the question. ABC is a triangle in which AB is equal to AC. Triangle ABC in which AB is equal to AC, right? And D is any point. D is any point on BC. Prove that AB square minus AD square is equal to BD into CD. D is any point on BC such that AB square. Prove that AB square minus AD square is equal to BD into CD. How will you do this one? So for this you need a construction. Draw AM perpendicular to BC. Draw AM perpendicular to BC, right? So here, therefore, by RHS property, right angle by RHS property, right angle hypotenuse side by RHS property, triangle AMB is congruent to triangle ACM. So first, in order to prove this one, you have to do like this. Then only you can arrive to this conclusion. Otherwise, it is impossible. So first, what I am doing is I want to prove that these two triangles are congruent. So see whether the letters are coinciding. AM, first letters. See here, AC, they are not coinciding. So what you are writing is wrong. So what I am saying is AMB is congruent to AMC. Now see whether they are coinciding on a letter B and C. B and C, yes. Because isosceles triangle base angles are equal, and given triangle ABC is isosceles. Isosceles means base angles are equal. Angle B is equal to angle C. This is given, right? Angle B is equal to angle C. Yes, they are coinciding. AM and AM, they are having common side. Angle, that's it. Enough. Angle AMB is equal to AMC. So therefore, by RHS property, these two triangles are congruent. You write down all the steps what I have discussed just now. Main points I am writing. Next, what else we can write? Therefore, from these two triangles, since these two triangles are congruent, I can write therefore BM is equal to MC, right? BM is equal to MC. So until here, any doubts? Draw AM perpendicular to BC by RHS property. These two triangles are congruent. So you write down all the steps. AB is equal to AC. Why these two triangles are congruent? Angle B is equal to angle C. Here by RHS you have written, no, you have right here AB is equal to AC, given because isosceles triangle. Next, angle AMB is equal to angle AMC, 90 degrees. I don't know, I am writing main steps. The remaining steps you should write by yourself. Angle AMB is equal to angle AMC, both are 90, and AB is equal to AC, given. Next, again AM is equal to AM, common side. So therefore these two triangles, right angle, hypotenuse and common side. So by RHS these two triangles are congruent. So until here, any doubts? BM is equal to MC. Therefore you can write BM is equal to MC. Any doubts? So nothing. Therefore next we will proceed further. Once you have written this one, then applying Pythagoras theorem. Since we are doing Pythagoras theorem, theoretical problems, write down. Consider triangle AMB. Consider triangle AMB. So consider triangle AMB. Apply Pythagoras theorem. AB square is equal to what? AB square is equal to Square on the hypotenuse is equal to sum of squares on the other two sides. dm square plus am square. Right? Next. Again, here ab square minus ad square. Now consider triangle ADM. ADM. Now AD square is equal to square on the hypotenuse is equal to sum of squares on the other two sides. dm square plus am square. Mark this as 1, mark this as 2. Are you following? I am considering this triangle ABM. Consider triangle AMB. Square on the hypotenuse is equal to sum of squares on the other two sides. AM square plus BM square. AM square plus BM. Now consider triangle, this triangle ADM. So ADM, AD square is equal to square on the hypotenuse is equal to sum of squares on the other two. AM square plus DM square. Now subtract. Why we should subtract? Because keep in mind what we have to prove. Never forget what we have to prove. AB square minus AD square. So you need to subtract this. Suppose if they give addition, you need to add that one. AB square minus AD square is equal to this and this gets cancelled. So BM square minus DM square, right? BM square minus DM. This subtraction. Subtract 1 from 2. 1 minus 2. You write down the steps. Now this LHS is over. We concentrate on this one. BM square minus DM square. BM square minus DM square. A square minus B square. What is A square minus B square? A plus B into A minus B. I am erasing all this. A square minus B square is nothing but BM plus DM. Next, BM minus DM. A plus B into A minus B. So BM plus DM. So just now we have proved that BM is equal to MC, no? BM is equal to MC. Right? So here you write down B in place of BM, MC plus DM. BM minus DM. BM minus DM. You write as is BM minus DM. So here in place of DM, why we have written CM means BM is equal to MC. BM is equal to MC. This already we have proved now. So in place of BM I have written CM. Are you following what I am saying? BM is equal to MC we have written now. So in place of DM I am writing CM. Now what is CM plus DM? CM plus DM. CM plus DM. CM plus DM is equal to CD. Right? Now BM minus DM. BM minus DM. This complete length minus this length is nothing but BD. See here. We have come to the conclusion that AB square minus AD square is equal to CD dot BD. Hence the theorem. Hence the problem. Very simple. It's interesting. Only thing is you have to prove that these two triangles are congruency by RHS property. Hence the theorem follows. Very simple. Yes, write down BM is nothing but CM. Therefore, CM plus DM is nothing but CM. This length plus this length. This length plus this length is nothing but CD. I have written. Next, this complete length minus this length is BD. That's it. There ends the problem. Next one.